This brings, of course, a question, and that question is about key management. Who knows what about you once you use that LPAV2 mechanism with an individual authentication or pre-shared key? Okay, so let's look into it. That's something you need to understand very clearly. First of all, the client. The client is going to generate this pairwise master key. In fact, what is going to be generated by the client is what we call the MSK, but that's a bit beyond the CCNA level. And from the MSK, the PMK, pairwise master key, is going to be generated. So that is something the client has. If you use 802.1x, the Radius server also has this MSK, and derived from that the PMK. So those two have it. And then the Radius server is going to pass that key to the controller and to the access points. So they will be receiving that PMK from the Radius server. If you use a pre-shared key, PSK, then in fact that PSK is going to be used as a PMK. So your pairwise master key is not derived from anything, it's just there, that's the PSK. So the client has it, and the access point has it as well because you enter those manually. So those are the keys that you have. Anyway, from that PMK, you're going to derive a key that you're going to use to encrypt unicast frames that you exchange between you and the access point. That unicast key is called the pairwise transient key, PTK. That PTK is actually the key material you use to encrypt traffic. And the good thing, as we said before, is that the PMK is never going to be sent, but it's there. So anytime you need, every few packets, few hundreds of packets, every few minutes, you decide, you'll be able to change the PTK. You just use the PMK and generate a new number and generate PTK index 9, index 15 from that PMK. And then you tell the AP, let's change, let's move to key index 24, and you generate from that PMK a new PTK. That PTK is the key material, and it can be rotated, as we say. It can be changed whenever you need it by just generating a new one from the PMK. Then, as you remember, the access point may need to send broadcast traffic encrypted to everyone in the cell. So the access point is also going to have what we call a group master key, which is pretty much like the PMK, but for broadcast traffic. This is something the access point generates on its side, okay? It doesn't send it. But then from that GMK, it's going to generate a keying material for broadcast traffic, which is called GTK, Group Temporal Key, which is the equivalent for broadcast to the PTK, that's for unicast. So the AP does that calculation for the group key from the group master key, generates group temporal keys whenever it needs to rotate it, generates a new one. And then it uses its encrypted traffic mechanism to each client to send to each of the clients in the cell the new GTK whenever the AP changes it. So at regular interval, the AP may be able to broadcast traffic, and when clients need to broadcast traffic, if they ever need to, they can also use that GTK. Whenever the AP decides, it can change that group key, use the GMK to generate a new GTK, and using unicast distribution is going to send that key to each client in the cell. So those are the keys that you have in the cell.